Right, it's what the people want, right? I mean, come on, what more could they want? Worked for Chappelle. All right, so here we are. What were we talking about, you're wondering, as the live stream starts, right? Dave Chappelle. All right, we did one in class, so skip it. Let's do two. All right, first off, concave or convex? Convex. How do you know it's convex and not concave? Yeah, so none of the angles are pointing inward. That's one way of looking at it. Another way is saying if I extended out these sides, right, would any of those sides intersect the interior? No, it wouldn't go through the interior, right? Another way, the way that I actually like the most, is none of these angles in here are greater than 180. If you have an internal angle that's greater than 180, meaning it's a reflex angle, then that's when it's going to be concave, right? So all of those are less than 180. There's a lot of them are more than 90, but they're all less than 180. All right. We know this is 5 because we can count. We know this is 5 because we can count. We know this is 5 because we can count. We know this is 5 because we can count. How do we figure out the sides that we're just not allowed to count? Bailey. So where is she getting these numbers from? Pythag, right? That's a 3, 4, 5 right triangle. Turns out all of these are 3, 4, 5 right triangles, which means this is an equilateral octagon. So all the sides are the same. And I said octagon because it has 8 sides, right? So that means the perimeter, if all the sides are the same, it's an octagon, and one side is 5. 5 times 8 is 40, right? Perimeter. Now, is this a regular octagon? First of all, what does it mean to be regular? Metamucil, fiber in your diet. What does it mean? What does it mean to be regular? It has to be equilateral. Lateral means sides. Equal means equal. So it has to have all the same sides. What else does it have the same? Yes, ma'am? Angle. So equiangular, which is a fun word to say. A lot of vowels. Are these angles all the same? Maybe, right? Bust out the protractor? No. Think logically. Check this out. 3, 4, 5 right triangle, right? That's 3. That's 4. Check this out. If I have an angle, okay, here's my angle, and it opens up into this side over here, right? What happens when I make the angle bigger? What happens to that side? The side gets what? Come on, class, wake up. Angle is here. Look how big the side is. Over here, right? The imaginary side. As I open up the angle, what happens to that side? It gets bigger, right? So bigger angles go with bigger sides and vice versa, right? If I want a bigger side, I have to have a bigger angle. So check it out. Which is bigger, 3 or 4? 4 is bigger. So this angle must be bigger because it opens up into 4 than this angle over here. What color am I going to use? I'm running out of good ones. I need to buy one. Oh, I did buy more. All right, this has turned into a unboxing. These are the G2 Pilot 07s. So they're not the 05s. The 05s are like really sharp. It's like writing with a knife. You want the 07s. So we got these. There's 12 in here. All right. So in here, you'll notice the 12 colors they give you. Like, they give you a black one, which is really nice. You'll go through that super fast. If you want to get black ones, though, I advise you to buy them all as like a black package. It's cheaper because you will go through them quickly. Brown, this color right here. Again, all of these are, if you look closely, they're all 07s. That's what you want, right? Sorry about the glare. I hope you can see that. 07. Okay, we got orange, which is such a great color. This purple right here is excellent for doing perpendicular because it's a perp pen. This one right here is like, how would you describe this? I would probably like a burgundy, a chartreuse, perhaps. We have red, like fire engine red. This is really good. This is great for grading all those papers you're going to give Fs to, although I give no Fs when I grade. This is pink. And then we have like 2 blues. We have like this dark blue, which you're going to think is the black one often, but if you look closely, there's difference. And then we have like the regular blue, which is a really pretty color, I think. And then we have 2 greens, and then like a blue that isn't really a blue, because this is like seafoam or like, I don't know, what would you call this? Aquamarine. It's not sky blue. This is light green, lime. It doesn't show up very well, as you can see on here. It's kind of hard to see. It's basically useless. And then we have the dark green, which is like the holy grail. All right, so which color are we going to use? Well, we already used orange, so I think we should probably use perps, right? We're going to use purple, green, and orange. What do they all have in common? Purple, green, and orange. They're all secondary colors, exactly. They're combinations of two primary colors. All right, so these angles are different. And this one's the bigger one. The orange one's bigger, right? Has to be because it opens up into 4. Now check it out. Pink plus orange should equal 180, right? Should, it's a straight angle. This pink, which may or may not be the same as this pink, we don't know yet. This pink and that purple should add up to 180 as well. But here's the problem. We know those are different angles, right? One's bigger than the other. So imagine, because you like numbers, right? We're not good at thinking in general. If that one's bigger, let's make it 40. Let's say the orange one's 40. Well, if that's 40, and this whole thing's 180, how much is the pink angle here then? If that's 40, and the whole thing's 180, how much is the pink angle? Take a guess. 40. The whole thing is 180. How much is left over? Yeah. 140, right? So if that's 40, that's 140. Now this cannot be 40, right? We know they're different angles. This one is smaller than this one. So pick a smaller number, like 30, right? If that's 30, what does this have to be? Should add up to 180, right? What's that have to be? $1.50, right? So because these are different, these purple angles have, or these pink angles have to be different. The only way for them to be the same was if these two angles were the same, and they're not. So we do not have an equal angular octagon. Those angles are not congruent. This angle here and this angle here, the two pink ones. So it's not regular. It's just equilateral. Moving on. Number 3. Ooh, this one looks fun. All right, convex or concave? Concave, it caves in. How do we know that? Because there's a reflex angle right here, my dudes. Right? That's 180 or greater. Non-inclusive. So this is concave. How many sides we got here? What kind of polygon are we talking? 6, which is a what polygon? Hexagon. The sixagon, which I will not accept as an answer tomorrow. Make sure you go back to the notes and on the videos and make sure you know the ones that you need to know, right? Triangle, quadrilateral, pentagon, hexagon. Don't need to know the 7. Octagon is 8. Don't need to know the 9. Decagon is 10. Dodecagon is 12, right? Because dec is the 12th month of the year, which is why dec means 10, right? December used to be the 10th month. Fun fact. All right, this is 5 because we can count. This is 5 because we can count. The other sides, if you notice, form a right triangle. All right, here we go, here we go. Seafoam, sky blue, what is this? Oh, yeah. Yeah, look at that. Doesn't do it justice. Let's turn up the brightness a little bit. Yeah. Oh, that's nice. Okay, so that's 4. That's 3. So what's our hypotenuse? It's a 3, 4, 5, right? 3 squared is 9. 4 squared is 16. Add them together, we get 25. Root it, we get 5. This is also a 3, 4 over here, so that's a 5. This is also a 4, 3, so that's a 5. That's also a 4, 3, so that's a 5. Yay, equilateral! It's a hexagon, so 5 times what is its perimeter? 5 times 6, which is 30. Boop. Perimeter's 30. Questions, comments, concerns on that one? Nah. Yes? 2 each. 1 for this thing and 1 for that thing. This is like whose line, guys. Everything's made up and the points don't matter. If you haven't figured it out yet, after we grade the homework, you can immediately correct it and then turn it in. It's for your health. Steve Brule. All right. Oh, we haven't watched Tim and Eric in here, have we? Oh, man, we need to do that. All right, here we are. Number 4. What kind of shape is this? What kind of polygon? Quadrilateral, because that's 4 sides. Quad means 4. Ri is a connecting word. And then lateral means side. So 4-sided. Is it concave or convex? Convex. I mean, it's pointy, right? But the angles, the internal angles, that's less than 90. That's less than 180. That's less than 90. That's less than 180, right? So all of those are less than 180, which means we have no reflex, you know, hyperextend your elbow angles. This right here, if I count correctly, is 13, and that's 13 as well. How would we figure out the diagonals? How do we do it? Come on. Calvin. Yes, I can. How do we figure out the diagonals? It's a good question, Mr. Maga. It's a good one. I don't know. It's stumping me. Oh, man. Air resistance. Thought it was negligible. Ellie.
Isn't it like for that shape you can just do like times width?
That's true. And why can we do that? No, it's okay. That's how you find the area of a parallelogram. You're absolutely right. The height here, right, is how tall it is, right? And this works because Pythag, thank you very much. So this right here is 12, if I count correctly, and this right here is 5. This is how you find the diagonals, guys. That's what we've been doing this whole time. We draw a triangle and do Pythag, right? So we have 12 squared. What's 12 squared? 144, right? What's 5 squared? 25. 25. And then we're supposed to root them, right? That's Pythag. So we got 169. Nice. Nice. I make my own quizzes and homework. What's the root of 169? You don't know this one? That's because you were mature back in the day and you stopped at 144, right? Everybody knows 12 squared. Thinking too hard. 12 squared is 144, and you're like, oh, that's all I need to know. Why go further? There's a reason. It's a good one. Root of 169 is 13. Just one more than 12. Now you know, and you'll never forget, because psychological scarring is a valid form of education. All right, so this is a 13 as well. And so is this. Equilateral. The sides are the same. Are the angles the same? No, dear God. That one's smaller than 90. That one's bigger than 180. Or bigger than 90, I should say. So 13 times 4. Let's do that in our heads for perimeter. 13 times 4 is hard. But you know what's easier? 4 times 10. What's that? 40. What's 4 times 3? 12. 12 plus 40 is 52. Again, instead of doing 13 times 4 in my head, I did 4 times 10 in my head, and then 4 times 3. Turns out doing it backwards is easier in your head. Questions, comments, concerns other than from my mental stability? Yes. Is this good enough for everybody to actually see? Is it? Or do I need to zoom in back and forth a lot? Bailey! Do you prefer zooming and moving? You do? Okay, that's what I thought. Calvin doesn't, but he sits in the second row. So who cares? All right, number 5. Oh, good God! Look at this thing. A monstrosity. How many sides does it have? So it's an octagon, believe it or not. Guys, same shape as a stop sign. You should recognize this by now. Convex or concave? Concave. Where do you see the reflex angle? HGF is a reflex angle, the internal one, right? Good job. Dang. Well done. Okay. Another way to think of it is convex, or concave things have external acute angles. It's another way to look at it, right? Same side of the coin. Right. All right. Now we need to find the sides. Well, this one's easy. That's 3. That one's easy. That's 2. And then it gets weird, right? So check it out. Doing Pythag. Let's find side CD. Well, CD has a horizontal value of 3 and has a vertical value of, how many squares do you count there? 4. Let me do a zoom. 3, 4, right? So that means CD must be what? 5. That's our 3, 4, 5 right triangle. Again, 9 plus 16 rooted is 5. How about this guy over here? Looks like 3 on the bottom, 4 vertically. Must be a 5 here. So those guys are congruent. What about EF? EF looks like 3 by 4. That one was already pushed down. 4. So that's going to be another 5. Let's do AH. Instead of doing it internally, I can do it externally, but I'm going to do it internally as well for this one. So that's 3 and 4 again. So that means AH is 5. Now the last one, HG. I'm going to do it internally. So between H and G horizontally is 3. And then vertically is also 3. Do you see that? So we have 3 here. And 3 there. What's 3 squared? What's 3 squared again? 9. So we add them together. 18. And then we root them. So root 18. It's all right. No one cares about calculation. That literally is not the point of math class. But I know you've been brainwashed over the years to think that's the only thing that matters. It's not. All right. So, oops, sorry. I'll do it in the bottom here. So let's add up all the sides. We've got a 3 plus a 5 plus a 2 plus a 5. Oh, we forgot one side. 1, 2, 3, 4, 5. That's a 5 there, right? Plus a 5 plus a root 18 plus another 5 plus my last 5. It's a lot of 5s. How many 5s do you see here?
5.
Incorrect. 6, because 3 and 2 makes another 5. We have 6 5s. That's 30. And then root 18. And that's all you can do. That's perimeter. Just like if that was x plus 5, you couldn't condense that any further, right? X and 5 don't go together. This doesn't go together. Yes. Please. Be insulted if you didn't. Fun question. What if the answer was actually 25 plus root 18 and another root 18? So I got rid of one of the 5s and replaced it with another root 18. Can we condense that anymore? And if we can, how would you do it? I want right answers and wrong answers. So if you raise your hand, you don't have to worry about what people think, because you might just be giving a wrong answer. Give me a wrong answer or a right answer.
Did you add the 2 roots together?
What would we get? 25 plus what?
36.
Root 36. Okay. So what she did is 18 plus 18 is 36. Okay. Good conjecture. Makes sense to me. All right. What's another way we could do this? Right or wrong? Another way you or a friend might do it on purpose or on accident. Can you think of any others? Right or wrong? Subtract them? Because like mess up the minus sign or minus for the plus. Yeah. Another way that's really common is to see people square them, even though it's not multiplication, right? So I'll see this a lot of the time. I'm glad you guys didn't think this, because that means you didn't think the wrong thing, right? We're not squaring because we're not multiplying, right? We're adding. And we know this can't be right because, well, we know both these can't be right, actually. Let me show you why. You don't have a calculator. You need to estimate root 18. How can we estimate what root 18 is? Any ideas? What's bigger, root 18 or root 25? Which is bigger? Think about it. I've got root of an 18 and root of a 25. Yeah. Root 25 is bigger, right? Has to be, because the root of a bigger number is going to be a bigger number. Now, what's bigger, root 18 or root 16? Root 18, right? Now, luckily, we know what root 25 is. What's root 25? We don't know root 18. That's what we're estimating. What's root 16? So root 18 is somewhere between 4 and 5. Make sense? Now check it out. What is root 36? 6. So I have a number that's between 4 and 5 plus a number that's between 4 and 5. Let's try and make it as small as possible. Let's pretend they're both 4s, right? The bottom end of the scale here. If they're both 4s, they add up to 8, not 6. Is there any way those two numbers could add up to 6? No, they're between 4 and 5, right? So that can't be true. Here, 18 squared before being rooted. Roots and squares cancel, so we get 18. Let's pretend this is as big as it possibly can be. What if they're both 5s? 5 and 5 is 10. Is that 18? Mm-mm. Can't possibly be that. This right here is somewhere between 8 and 10, right? Because this is between 4 and 5. So 2 of them should be somewhere between 8 and 10. I don't want you to write down the decimal. I just want you to think critically. If I have 2 root 18s, right? You've got 1 root 18. I've got 1 root 18. How many root 18s do we have? We got 2 of them, right? So 25 plus 2 root 18s. That's what that means. You've seen it before. 2 times root 18. No, 2 root 18s. It's like having 2 x's. You've got 2 root 18s. More right. Or at least, no, this wouldn't be because I changed the problem. That's the answer. Questions, comments, concerns? Now, if you, on your test tomorrow you have 2 root 18s, I would prefer to see it like this. 2 times root 18, not just root 18 plus root 18. Cool? Kosher? Wonderful. And again, if I had a root 18 and a root 17, I wouldn't add them together, right? And get root 35, 35, right? That would not work. They'd have to be separate because they're different roots. Those are both the same root, so I have 2 of them. Turn the page. Draw an example of a convex regular pentagon. All right, let me get on my protractor. No. Pentagons have how many sides? 5. Here's 1, 2, 3, 4, 5 sides. It's regular, so that means it's equilateral, right? I made it equilateral by saying it was. Is it actually? Good Lord, no, right? Now, to be regular, you need to be equilateral and what? What do you say? Not equal distance. Different. That's equidistant is another equal word that we use, though. The sides have to be the same. What else has to be the same for it to be regular? The angles, right? Equiangular. So I tell you that all these angles are equal. Are they actually? Good Lord, no. But like, who has time for that? Just write it. It doesn't have to be drawn to scale. Now, if we wanted to bust out our protractor, fun fact, every polygon except one, their internal angles all add up to 360. True or false? That's on YouTube. We don't know yet, do we? Maybe that can be a self-development problem. Do all of these angles have to add up to 360? Is that a thing? It sounds like it should be a rule. I don't know. Moving on. Number 7. Concave triangle, true or false? Can we have one? No, why not? What does something have to be concave? I can do it with 4. I can do it with 3. No, I can't. I can do it with 4. What does something have to be concave? That's a great question. One of its internal angles has to be what? She's thinking. The internal angle, at least one of them has to be greater than what? Greater than, Bailey? 180. You have to have a reflex angle internally, right? So one of the angles, if it's concave, it has to have one of its angles be greater than 180. Now maybe you know this, maybe you don't. What do the internal angles of a triangle always add up to? This angle and this angle and this angle always add up to, no matter what it is, to 180 degrees. So my question to you is, how can I have one of the angles be 180 if all 3 have to add up to 180? 2 of those angles better be 0, right? Now we have a flat line. That's not a triangle. Do you see how this can't be concave? It's impossible. Can you draw a concave with 4 sides? Yes, you can. Like this. That's concave because that's greater than 180. All I do is take the triangle and put a point on the inside and bend it, right? Self-development, do it or don't, doesn't matter to me. If you want to keep working on it, turn it in at the end of the semester, knock yourself out. That's the thing. So everything's worth 2 points. So we have a total of 12. Mark it, give back the grade, and then decide whether you want to turn it in or correct it. I would always encourage you to correct it because you could literally correct it right now for free points. Or don't, yeah.
Those are on 6 and 7. Each card is 1 point and 2 points.
They're both 2 points. Good question. If you love your grade, keep it, or turn it in. If you don't love your grade, correct it. And then get the full points either way. The whole point is learning. Now it's time for the review. We aren't going to have time to do all of them, so I just want some nominations for problems you want to see. Although we can cut to the chase, I probably know which ones. Well, everyone is worth seeing. Yeah. Yeah, so 1 point for naming the shape, right? And then 1 point for finding the review. Those are worth 2. Just because I'm nice. Everyone, how many problems? We have 7 problems. 2 times 7 is 14. It's not a 14. It doesn't matter. I don't know what. Oh, I just added incorrectly last hour. Yeah, last 2 should be worth 1, but it doesn't matter. It doesn't matter. It doesn't matter. It's fine. It's fine. Totally fine. I don't have one anymore. I'm sorry. You can go to that. I know. Numbers are hard. No. Okay, the big thing on the top right corner of this is an R, and I wrote that because if you look at the heading, it says Geometry Test Number 1. This is not the test. This is the review guide. What I do to make the review guide is I take all your homework and quizzes and throw them together in one document, and then I cut out the ones that overlap, I change the numbers, and that's your review guide, right? Then I take the review guide and make it into the test. And how do I do that? I take out the ones that I think overlap conceptually, right? That'd be a waste of your time to do twice. And then I eliminate all the extras, thank you. And I also cut out the problems that I think that aren't really a challenge, right? Save you time. And so when I do that, sometimes I have the heading on late, and I call it test 1 because that was the thing I ended on last night, and it copied over to this guy. So it's not the test. Don't memorize this. You can come in the next day and get them all wrong, okay? The numbers are all different. And the test won't be nearly as big. I don't remember how many problems are on it right now, but it's not that many, okay? I mean, there's only 14 on here, right? So I'm going to guess, and you can correct me if I'm wrong. You're going to want to see number 2. You're going to want to see number 3. You're going to want to see not number 4, but number 5, because number 4 is just midpoint. And I bet you're going to want to see number 6. You're not going to care about 7 or 8. You might want to see 9 through 12, maybe, but not really. It's not that bad. All that's different is there's an X here instead of a number. So we'll hit that one last if we have time. And you're going to want to see 13. Anybody object to those? No? Okay. I figured we'd save democracy and I could just install myself as dictator. Save everybody time, right? All right, here we are. We want to find CD for this one. Well, what is CD? CD is this right here, okay? That's what we're looking for. Not X, but CD. We need to go find X first, though. Here's the logic. Watch the show, screenshot when I'm done. Don't try to copy all this crap down. This isn't due for a grade, okay? The only reason you'd ever look at this again, or I'd ever look at it again, is if you needed to review this, right? So watch the magic happen in real time. Screenshot it if you want the answer, okay? Here's what I'm going to do. The logic is this. This piece plus this piece should equal the whole thing. However, it overshoots, doesn't it? Notice that this guy already counts the middle, right? And this guy counts the middle again. So if we took out one of the middles, we'd have the right amount, wouldn't we? We'd have this plus this. Are you digging? So I'm going to add up this guy, and then I'm going to subtract one of the middles. I'm going to subtract 3x. You smell what I'm stepping in? Again, that's what happens when you watch the magic instead of trying to scribble stuff down. This class is most guilty of that. So we have x plus 7. That's this bit. Plus this bit, 11x minus 2. But that overshoots by 3x, right? One group of 3x. So we're going to subtract 3x. Now, we need an equation here. What should that add up to? This piece and this piece minus that piece should add up to what? They're doing it again. They're writing stuff down. You can tell because then they don't know the answers. Should add up to what, Nelly? The whole thing, 13x minus 3. Now we just do some basic arithmetic and algebra, right? We get our x's together. Terrible idea in real life, great idea in math. We have 11x's plus 1x, that's 12x's, minus 3x's is 9x's. And then we have 7 minus 2, which is positive 5. We have 13x minus 3 on this side. Again, we're going to get our x's together. I'm going to move over the 9x by subtracting. And I get 4x. I'm going to add the 3. Then I'm going to get 8. Then I'm going to divide by 4, because that's how you do separation, right? Divorce. X equals 2. Why are you writing this down? You can literally just screenshot it. Are we done? No, we need to find CD. So how do we find CD? Well, this is basically CD, but it's too long, right? How could we, what could we subtract from this to make it the right size? 3x, right? If we subtract that bit, we get the right size, don't we? So whatever this is, CD is going to be 11x minus 2, this bit, right? Minus the piece that goes too far. Minus 3x. Well, that's going to be 11x minus 3x is going to be 8x minus 2. What is x again? 2. So 8 times 2 minus 2. That's 16 minus 2. That's 14. CD is 14. It's the hardest one I could throw at you. Right there. Let's see if you see the logic. These two pieces added up will get me the whole thing, except they get me the whole thing plus one extra middle part, right? So this guy plus this guy minus the middle part gets me the whole thing. Write that down. Do math. Find 2. Or find x, I should say. This guy is 11x minus 2. I only want this bit, though. So what I do is I take 11x minus 2, and I subtract the 3x I don't want. Then I plug in 2. Are you seeing the logic? That's the important part. Try 1, try 2 without looking when you get home. Number 3. Turn the page. This one. All right, so start with the Pythagorean theorem. All right, I'll do that. What is Pythag? Thank you, Macy. A squared plus b squared equals c squared. I swear to God, everybody should get that as a free point. Start with Pythag. Then it says work your way to the distance formula. Well, in order to get there, we have to show what we're going to switch a and b out for, right? And we have to show why that is. You can't just say, oh, a and b are 5 and 6 because I said so, right? You have to prove it. So here's what we're going to do. Your triangle. You want to label its points. I always start with the bottom left. You can choose whatever you want, but I would go with the bottom left. Let's call that x1, y1, because we don't know what it is. And it's our first set of x and y, right? Let's look above this to the next point. How are these 2 points different? Are they the same vertically or different vertically? Vertically speaking, are they the same or different? Think about it like an elevator. He's on the first floor, he's on the 12th floor, right? They're not the same vertically. They're different vertically. So the y values are going to be different. So if that's y1, that has to be y2. It's like a logic puzzle. Are they the same horizontally? Well, if I move across the page horizontally, I hit them at the same time. See how they're the same horizontally? So they have the same x. Awkward. Both are x1. Let's do the same logic over here. Compare these 2 dots. How are they different? Vertically or horizontally? How are they different? If I'm standing here, which way do I have to move to get to this one? Horizontal or vertical? I have to move horizontal, right? Because I have to change my horizontal position. Because it's different. He's at a different horizontal position, right? Just like this guy's at a different vertical position. Now, are they different vertically? No, they're on the same floor, right? Think elevator when we think vertical. They're on the same floor. So they're both on floor y1. Now, what does this tell us? This tells us that A is going to be equal to the distance between these 2 points, right? That's how long A is. It's going to be the distance between these 2. Distance is what? Subtraction. Thank you, Landry. So we subtract the x values. What's the x minus x? Or x1 minus x1? 0 goes away, right? What's y2 minus y1? Well, that's the thing that stays, y2 minus y1. So when we subtract the x1s, they go away because any number minus itself is 0, right? x1 minus x1 is 0. These guys we don't know, so we write that down. And that makes sense, because what this is saying is y values are vertical, subtraction is distance. We're talking about vertical distance here, aren't we? A is vertical distance. So we write that. Vertical distance. Now, in my diagram, A is over here. Tomorrow you might have A down here. That might change things, right? Might want to think about that. Don't memorize this. Think about what it means. B, on the other hand. If we want to know how long B is, we need to figure out its distance, right? Distance is what? Subtraction. So we're going to subtract the x's and the y's. Notice if we subtract y1 from y1, we get 0, right? Any number minus itself is 0. What's x2 minus x1? Well, that's what stays, because that doesn't become 0, right? Now, why does B get the x's? Because B is horizontal. And why are we subtracting? Because distance. Horizontal distance. I need this. Okay? After you have that, we know what A is. A is this. We know what B is. B is that. We can plug them in. So something squared plus something squared equals C squared. What are we switching out for A? In this problem, what do we switch out for A? A used to be here. What are we switching? Nelly. Y2 minus Y1. Right, that's where it is. A is that, so we can switch them out. B, on the other hand, is x2 minus x1, so we're switching out here. This might look different than what you're used to. You used to having the x's first, right? It's because normally I have A down here and B up there. That's the only difference. Right, if A is down here, then we're talking horizontal values. It's going to be the x's. If A is up here, like it is here, it's going to be the vertical values. That's all. Now, last step, we got to get rid of that root, right? Here's what I'm going to do. Everything under the root on this side, get rid of the square on that side. Done. Made it to this as the formula. Questions, comments, concern? Let's break it down. Start with Pythag. Plot your points. These are different horizontally because I have to travel horizontally to get to it. These are different vertically because I have to travel vertically to get to it. A is going to be these guys subtracted. These go away. These stay. B is these guys subtracted. These go away. These stay. Y is A, the y values. Vertical, distance. Y is B, the x values. Horizontal, distance, subtraction. Plug them in. I would encourage you to go back and watch that in slow-mo. Ready to move on? Here we go. Skip 4, go to 5. 5 asks you to use distance formula as well as section formula. We're going to do distance formula on another problem, so I'm going to skip that for now. You cannot skip that tomorrow if the directions say you have to do distance, though. Okay? So section formula says we have to have an M and an N ratio. Let me zoom in. So they give us a fraction of 5/7. What's the ratio we're talking about? It's not 5/7. 5 to 2. Now, how did you know that? Because the 5 comes from here, and the 2 comes from what's left over. If I have 5/7, how many 7s are left over? 2 more 7s, right? That makes 1. So the 5 and the 2 come from here and here. Now we're going to use section formula. Remember, section formula says we're going to average the x values. And we're going to average the y values. Average means add them up and divide by the number of pieces, right? So we're going to add them up and divide by the number of pieces. Now, how many pieces will we have here in total? Well, we got 5 of one of them and 2 of the others. How many total pieces do we have? 7. So we're going to divide by 7. That makes sense. 7 total pieces. Where are those 7 pieces coming from? Well, we're going to have 5 of one of our x's, and we're going to have 2 of the other x, right? That's where that ratio comes into play. Same over here. We're going to have 5 of these y's, and we're going to have 2 of those y's. Now the question is, what are our x's and y's? Well, if you look over here, they give it to us. x1 and y1 are a's values, because a comes first. And x number 2 and y number 2 are b's values. Now, in section formula, you have to be careful. This is the mistake everybody makes. They plug in this one first because it's x1, and they think, oh, I'll start with the first one, right? Wonderful, excellent, fantastic. It works for everything except this formula. This formula is specific. It says you have to take the second guy first. It's kind of weird. So x2 is going to go first. So instead of 5 times negative 6, which is what a lot of you probably would say, it's going to be 5 times what? 1. And the negative 6 comes after that. Remember, we're averaging both of the x's first. Add up your x pieces and divide by the number of pieces. 5 1s, 2 negative 6s. Then we're going to do the y values. Again, y2 comes first, not y1. So we go over here to y2. That's negative 8. And then we look at y1, which is negative 1. And now we just do arithmetic. So p is going to equal all that divided by 7 for both of these. What is 5 times 1? What's 2 times negative 6? Negative 12. 5 times negative 8? Negative 40. 2 times negative 1? Negative 2. And if you notice, 5 minus 12 is negative 7. When we divide that by 7, we get negative 1. Negative 40 divided by negative 2 is negative 42. When we divide that by 7, we get negative 6. Whoops, sorry, tell me I'm zoomed out. Or zoomed in, I guess. So again, 5 minus 12 is negative 7. Negative 40 minus negative 2 is negative 42. Divide by 7, we get negative 1, negative 6. Plot your points. A is negative 6. 1, 2, 3, 4, 5, 6, negative 1. That's where A is. B is 1, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. When I connect them, which you better do tomorrow, remember that's a point, I get a line segment. And if I plot my point, this guy right here, negative 1, negative 6, check it out right there. Makes sense to me. That looks like it's about 5/7 of the way between A and B. If you had flipped your x's, so instead of doing x2 first, you did x1 first, you would have gotten this point over here. Because that's 5/7 the way going from B to A, right? If we start at B and go to A, that's 5/7 of the distance, right? So order matters. You want this dot, so x2 comes first. We didn't have enough time to get to a lot of these. What I want you to do is watch the review from another class if you need help with the rest. I'm going to try to today before I head to DeKalb to squeeze in a video of me just going through all of it. But if I don't do that, first hour to get through everything, and I think most of the other hours will too, okay? You'll be okay. Watch that video. Try this packet. If you can do the whole packet, easy A. If you can't do the whole packet, well, it's going to be less than an A, right? Work together. Review. This is a test tomorrow, not a quiz.